Hello everyone and welcome back to JL Tech. In today's course I'm going to show you how to build a .NET Core Web API with .NET 8, and that will be tied in with Entity Framework and SQL Server. A couple of prerequisites for this course: you will need version .NET 8 installed on your machine, which you can get from the official Microsoft download links down below. You will also need SQL Server 2022 installed, a version of SQL Server instance, SQL Server Management Studio, and some very basic knowledge of C#. This course won't include how to set up SQL Server or creating any database structures. Let's dive straight into it. Once you've downloaded and installed .NET 8, you can close this down and open up Visual Studio. Once in Visual Studio, on the left hand side you may have an ASP.NET Core Web API if you created a project like this before. If you haven't, you can select it on the right hand side as shown here. Let's give our application a name. I'm going to call this Ticket Demo.NET 8. Let's click Create to create our solution. In this tutorial, I'm going to show you the best practices for structuring a project. So rather than having a fat controller, if you will, with all of our business logic and our database, I'm going to properly set up some repositories services with interfaces and dependency injection, so we're properly teaching you the best practices for the real world. To do that, what we'll do is we'll right click our solution and we will click Add. In here we will click New Project, and the project type we want is going to be a class library. This one we will call Database, as it's going to handle all of our database logic. Again, we will click .NET 8 Long-Term Support. This is our database project. This is where we'll store all of our details relating to our database and our database instance. So if we ever need to, let's say, create another project, we can just add in this database project to our other solution using dependency injection, and we can reuse the code, and we don't need to have this project on multiple projects. What we'll do is we'll just create this nice and neat. So we'll add a new folder in here and we'll call this one our entities. And what I'm going to do is I'm going to add a new entity, a new class even, and this class is just going to be called the JL Tech Context. Once we're in here, we can change this to a public class, and this will inherit DB context. Oops. Now if you don't see DB context, this is perfectly normal. So what we'll do is we'll go up to database at the top, manage NuGet packages. We'll click browse. And then in here we'll type in Entity Framework. And the version we want is Entity Framework Core. The latest current version is .NET 8 0.5. We'll click Install and Apply and Accept. And if we go back to our context, we should now be able to right click Control plus dot and using Microsoft Entity Framework Core. We can create a constructor. We can create a constructor within this class by typing in ctor and hitting tab. This will automatically create us a constructor, which then inside we can go DB context options. We can put in the name of our context, which is the JL Tech context, and give it a name of options. And then outside of that we can inherit from base and pass in our options again. We already have our braces there, so we don't need them again. So that's our constructor for our context, which we'll come back to later. Next up we have our entity. I'm just going to show you one entity in this tutorial, and our entity is going to be called Ticket. If we look at our SQL Server instance, which I have here, we can see we have a small table that's called Ticket, and it takes a ID of an integer, a priority status of an integer, a description of a varchar 150, and a status of an integer. So let's create our class to suit that. We'll change the class to public, and then what we'll also do is we'll start adding in some props. So you can see here that IntelliSense is telling us that it knows this is going to be an ID, but if we're doing it the other way, we can type in prop and hit tab, which will create us a new property. We know this is an integer, so we can hit tab again to move to the next property, and we can call this ID. We can do the same again, so we can say prop. The next one is priority, that we know is a integer as well, so we can type in priority. Our next one is a string, so we can say prop string, and this one is going to be description of our ticket, and we'll initialize this as a string.empty to get rid of that green error below description. Last but not least, we have a status. Now, if our table at the moment is called ticket and our class name is called ticket, so Entity Framework will be able to successfully direct to this table. However, just to be on the safe side, I'm going to tell Entity Framework what our table is called anyway. So we'll add in the table parameter here, and inside we'll just put the name of the table, which is ticket. And we're going to remove any unused references at the top. One thing that we can also do, if we look again at our table structure, we can see that ID is a primary key, so we'll tell Entity Framework about that as well. Perfect. Now what we can do is register our database in our application. To do that, we'll go to our actual API project, dependencies, add project reference, and we will tick our database project. There's a few things that we're missing here, so now let's right click our web API and go to manage NuGet packages. From here we can go to browse and again type in Entity Framework core, and let's install that. And then because we're using SQL Server, we also need to download Microsoft Entity Framework Core SQL Server, which at the moment has 476 million downloads. Let's go ahead and install that. Perfect. Now we can go to our app settings.json, and at the top we can bring in a new section called connection strings, and we're going to call our connection string default connection. This can be whatever we want it to be called, but we're just going to go with default connection for now. Now this is where you need to be 100% sure where you've configured your SQL instance. Mine is localhost, so we can say server equals localhost. My database is called JL, no it's not, it's called .NET 8. My user ID is JL Tech. My password is password, very secure. We can do trusted underscore connection equals true, and we can also do trust server certificate equals true, semicolon. Perfect. So now what we can do is we can go into our program.cs, and anywhere above line 10 where it says app build, builder.build, we need to add in our dependencies. So we need to register our database context here. So we'll do builder.services, add db context, and this is a JL Tech context. And then in brackets, we could leave it like that. But we now need to tell it where our database lives in terms of the connection string. And we can do that in here via dependency injection by saying options. And now, because we've created a object up here, a parameter called options, we can reference options and say use SQL Server. And then in here, we can now say builder configuration get connection string. And then in here, we can put default connection. The reason why we've put default connection is because in our app settings.json, we specified this as default connection. If you had this as default connection 1, you'd also need to put default connection 1 in here too, but we're not going to do that. Perfect. Now what we can do is we can tidy up our controllers in here. So the weather forecast controller we can just delete. Our weather forecast we can delete. And let's go ahead and create a new controller. If we hit API on the left, and we'll do an API controller empty. Make sure you keep the word controller in this class, and what we'll call it is our ticket controller. Perfect. Now when we call this API, at the moment you can see up here our root is expecting us to pass in the word API /. I typically don't like using that, so I'm going to go and remove that and just have our root as our controller. Perfect. Now I did mention at the start of the course that we'll be using dependency injection, so we're going to create a couple more class projects. Let's go ahead and right click our solution, click add and new project. We want another class library. This one we will call interfaces. Delete class 1 that was created by default, and then we're going to create one more project. This time we'll call this one business. This one will house all of our business logic for this application. I'm going to create a few models within business here, such as add, new folder, and let's create one called models. We can create another one called services. And let's create another one called repositories. In our interfaces project, let's go make another one similar. So we'll add a new folder called services, and we'll go make another folder called repositories. Perfect. Now in our interfaces, let's right click repositories and go new item. Make sure you have interface selected and that the naming convention starts with a capital I for interface. Now it can be called whatever we would like. We will say iTicket repository. We'll change this to a public interface. We'll do the same for services. Making sure we've got interface selected, that it starts with a capital I, service, iTicket service. And once again, we will make this a public interface. What we can now do in our business project up here, we can right click dependencies, add project reference, and we can now reference our interfaces projects. So we can just tick interfaces and click OK. Perfect. Now what we can do is in our repositories folder in our business project, we can right click new item. This time we'll create a class, and this time we're going to create our repository. So we'll say ticket repository. Bearing in mind this is now a class and it does not have the capital I at the start. We can make this public as well, and at the end we're just going to inherit, so we're going to put a colon here and we can just say iTicket repository. And you can see that's added a reference up here to interfaces.repositories. We'll just remove any unused references just for now. We'll do exactly the same for services. Ticket service. We'll make it public. And we'll inherit from our iTicket service. And once again, we'll get rid of any unused references. Perfect. Now what we'll do is we'll go back to our web API here and we'll right click our dependencies and we'll add a project reference. We'll need to add references here to the interfaces and also our business project. And hit OK. Now we need to be able to register these dependencies as part of dependency injection from our web API project. We'll do that by going to our program.cs, and above this line where we actually build the application, we'll just register the services. So we'll say builder.services, And you have a few options here. You can highlight over the different options and it will tell you a little bit about each one. For instance, you can register it as a singleton service, as a scope service, or as a transient service. We're just going to use scoped for this example as I find that works best. What we want to do in here now is we want to first of all register our interface. So we'll say iTicket service. So that's our interface, and now we need to register the class or the service that will be inheriting this, which will be our ticket service. Perfect. We now need to do the same for our repository. So we say add scoped iTicket repository and ticket repository. Now, even though this is a repository and we're adding it as a service, this is just completely normal. I know that's tripped over a few people that I've worked with in the past. It's just completely normal and it doesn't make a difference. Perfect. Now what we can do is we can start adding some logic talking to our database. So let's start off with our ticket controller, and we're going to make a new method. So we're going to say public async task, which is asynchronous, and we'll have this as an iAction result. We'll say create ticket, and this will be a post method. Perfect. Let's duplicate this, and we'll just create one more for updating the status. And just to get rid of those exceptions, we'll just return OK in both of these just for now. Perfect. In our models folder that we created on the right hand side, and I'll just close all these other windows down for now. So we're in our business project, our models. Let's now go and create another folder, and we'll just call this enums. And then inside here, we're going to create a new enum. This will be ticket status. And what we'll do in here is we'll call this a public. We'll replace class with enum. And we can now go and create some enums. So we can say we'll have a ticket that may be open. We'll have one that is closed. Perhaps we'll have one that's blocked. Awaiting customer. And I think that'll do for our examples here. We can remove any unused references from our top just to make our code look a little bit neater. We're going to create another enum. And for my example, we're going to say ticket priority. Again, we'll update internal to a public, and we'll replace class with a enum. And we will have low, medium, high. Now you might be wondering why I'm creating enums, and essentially this relates back to our database structure. So you'll see here we had an ID which is just auto-generated, we have a priority which is an integer, and we have a status which is also an integer. So instead of storing in our database whether something as text, whether it's high, low or medium, we'll just store the integer, which will keep our database nice and small. Perfect. Now let's go and create a object here. So we'll create a new model and we'll call this ticket DTO. We'll make this public, and very similar to what we did before, we'll just go and create all of our options. Now just for speed, if we go to our entities from earlier, we can just copy and paste all of these from our ticket into our DTO, which is a data transferable object. Perfect. So now let's create our first method to update to create a new ticket. So if we go to our interfaces in our repositories first, so we'll start at the very top. So we'll go to our ticket repository and into our ticket repository interface. we'll create a task that is called add, and this will take in our ticket DTO model. We can right click quick actions. So you can see here, this project doesn't have access to our new models, which is absolutely fine. So in our interfaces project, let's just right click dependencies, add project reference, and we'll just reference business. Okay, so what we've done here is we've actually created a circular reference, which is wrong. So what I'm going to do is in our models, our ticket DTO are created in the wrong place. So what I'm going to do is I'm just going to copy that and paste it into our database project. So I'm going to create a new folder called DTOs, and then I'm just going to paste that object in there and remove it from the other one. Perfect. So now when we go into here, if we save this and we uncomment out this object here, we should now be able to add a reference from our interfaces to database, and we should now be able to use our models. Perfect. Once again, we'll remove even any of our unused references. Perfect. What we can now do is go back to our ticket repository, and we can right click our interface and click into implement. At the top here now, we need to register our context, so we'll say we are introducing a private read-only JLTech context. We'll just call this context, and then we're not going to actually create a new instance of it. What we're going to do is we want the initial one passed in. So I did the ctool command there just to create a constructor, and we're also going to pass in JLTech context and call this something else. And then in this constructor, we can say, well, our variable at the top, context, can be set to the context that's passed in. Now, we're adding in here a model that's got nothing to do with our actual database entity. So although the contents that are the same inside in terms of the columns, they're actually two different files. So we'll have to do this a different way. So we'll say await context dot tickets. So we actually haven't added our context yet. So let's right click our context here, and just under our constructor here, we can say public db set, which is a ticket, and we can register our table. So a db set is our table in Entity Framework. So back in our repository, we can say we want to talk to our database, which is our context. We want the tickets table. We want to add a sync. Now, if this object up here was a ticket, which is the same type, we could have just passed in ticket, because they're both the same models, and it would have allowed that to happen. However, we're passing in a ticket DTO, so now we're not actually adding the same model here, which is going to give us a conversion error. Cannot convert from business models ticket DTO to database entities ticket. So what we'll have to do here is we'll say, well, we want to create a new ticket then, and if we just add some braces inside, we can then say, well, our ID is so and so. Our what else was there? Let's have a look at our database. So we have a priority. So our priority is called that. Our description is that, and our status is that. We can now also use an await function await our context save changes async. So essentially what we've done is we've converted our ticket database transfer object into an entity ticket so that it can save to the database. Perfect. Now what we'll do is we'll go into our interface. That all looks good from there. So what we can do is we can now go into our service. So we'll go into our service, and we'll do exactly the same here. So what we'll do is we will say a task of add that takes in a ticket DTO. We'll remove any unused references, and we'll go into our function here, and we'll implement our interface. Now, we're not going to add in our database here. What we need to do is add in our repository. So we can say private read-only iTicket repository, I'm just going to give this an underscore name here. Let's create a constructor by doing ctor tab. And then let's say iTicket repository. And then let's set our variable up at the top, our read-only variable, to the one passed in via dependency injection. Now, if we needed to make any business rules here, our business rules would be placed in the service. So if we wanted to, I don't know, do anything in particular, whether it's a very complex database and you're splitting things, or you're doing validation, that would all happen in a service. You shouldn't have any business logic in a repository. The repository is purely for adding, saving, or amending, and doing data trips, which will really help, especially when you come to the unit testing on this project, which we'll do in a future video. So for now, what we'll do is we'll just say we want to await this function, and we're going to call ticket repository add ticket, and that is it. What we can now do is we can go to our controller method, ticket controller, and at the top here we will just do a private read only. We want an iTicket service because we always go via the service. We should never go directly to a repository because it's bad practice. And we'll go ticket service. And again, we'll need a constructor. Have our iTicket service, ticket service. In our create tickets, we need to add in our ticket DTO. So let's say ticket DTO of the name ticket. I'm not so much worried at the moment about the update status function, so we'll leave that there for now. But in here, we'll set a try catch. And what we'll do is we will say await ticket service add ticket. If that works, we'll return OK with a it worked. If we get an exception for whatever reason, maybe we've done something wrong, we will return a bad request. We'll do some and we'll return it failed, and we'll return our exception in there too. Perfect. So to summarize, we've created some interfaces in a separate project. We've referenced them in our program.cs as scoped services, along with our database connection. And then we've created interfaces to host our headers for these functions. And then we've implemented these interfaces in our repository to talk to our database to make some changes. So now let's go ahead and debug this application. While we do that, if we look at our SQL Server database, if I just execute this, you can see we currently have nothing in this table whatsoever. So let's let our API start up. And straight away, we've got an exception here, failed to load API definition. So let's have a look at what we did wrong. If we start off at our ticket controller, let's try another method called root. And we'll call this one create. And we'll create another one for update. We know it's not related to our API, so we'll remove that again. There we go. So we'd have simply just forgot to specify our root for our endpoint. So in here now we can go to our post and we can see we have an ID of 0. So let's say hit try out. We'll have an ID of 10. We'll have a priority of, let's say, 1. Our description will be, this is my first ticket. Please help my issue. And we'll set the status as 2. Again, we're not really doing any validation here. We can, of course, add validation in the future to check that a status is valid, etc. But if we hit execute, we can see that the error is actually an error code 400. So we cannot insert explicit value for identity column in table ticket where identity insert is set to off. So what we actually need to do here is we've made a bit of an issue. So if we just go back to our ticket repository, we've explicitly told it here to use our ticket, which we don't need it to do because we've told our SQL server in our design view to use identity specification for our ID column. So that's why that exception is being thrown there. So what we can do now is let's just debug that again. We'll go create, try it out. We can leave ID blank now because it doesn't matter. Priority will set to 1. This is my first ticket. Status will set to 2, and let's hit execute. We can see here it says it worked. Didn't mean to do that. So now what we can do is refresh our database, and we can see we had a record inserted. We have a priority of 1. This is my first ticket. Status of 2. Perfect. Now let's have a look at getting a record out of the database. So we'll do a very similar approach. We will go to our repository, and we will now do one called, which will be a, oops, it's trying to predict what I want to do, which is interesting. What's going on here? Format's in a weird place. There you go. Instead of an update, we're actually going to do a get. Our parameter will actually be an integer. We'll say ticket ID, and we're going to return, as part of our task, we're going to return a ticket DTO this time. Perfect. We're going to copy this, and we're going to go to our iTicket service interface because we need it there as well, and we're just going to paste it in. Now let's go back to our ticket repository, and we can right click our exception up here, and we can implement our interface. Down in here, what we can do is we can say return, await, context, dot tickets, and we also want to return a DTO here. So again, if we wasn't returning a DTO, we could just return first or default, where our ID, oops, x.id equals our ticket ID. And if this was a ticket type, that would then work, because you're returning a, this also needs to be first or default async, because you're returning, and if we just change this to first, just because we're not telling it that it's a null, async, you can see this won't error, but we're not returning a ticket, we're returning a ticket DTO. So again, once again, this fails because we can't do that conversion. So what we need to do is we need to, after the table name of ticket, we need to do a select, and we'll call our object inside an X, and we'll say new ticket DTO, and we'll add some braces. At the end of that, we'll say first async. There we go. So now we can target what we want to return. So we can return our priority, we can return a description, and we can return a status. Perfect. Now what we can do is we can go to our ticket service, and we can just do exactly the same. We'll implement our ticket service. Now this function is going to return something to the user, so we need to start with return. It's an asynchronous function, so we're going to await it, and you can see IntelliSense there has finished what we started, so we'll say ticket repository get and our ticket ID. And I think I actually missed something off on the previous one, which I did. So what we'll say is, just before we do our select, if we push that down to a new line, we can actually still do our where clause. So we can say where, we'll let IntelliSense finish for us, where our ID equals ticket ID. That's looking good as well. So we can go to our controller, and we'll just change this to a get ticket. Didn't mean to do that. I should change that back to ticket DTO and change this to a get. What we could say here is var result. We'll do a try catch as well actually. just like before. We'll do a var, and we'll say our result is equal to our ticket service get, and we also need to change this to an integer of our ticket ID. If that's fine, we'll return our ticket, and this also needs to await this function because it's asynchronous, and once again we'll return a bad request if it failed, like so. So let's go ahead and debug this, and we'll just go ahead and create another ticket in here. So this will say this is my second ticket, and we'll do one more. This is my third ticket. We can see those both worked. So we can see in our database now, if we refresh, we have an ID of 2, 3, and 4. So now let's try use our API to actually get one of these objects. So if we go back to Swagger, go into get, and we can pass in our ticket ID of, let's say, 2. We can see here that this has returned, this is my first ticket, which if we look for ID 2, it says this is my first ticket. Let's try number 3. This is my second ticket, and number 4 will be our third ticket. So their API is correctly returning an object for us. So now we're in our ticket repository, we'll go ahead and implement that interface. In our update, what we can do is we can just say var existing ticket equals context ticket. We can do a find, or we can do a first, and then it will be a asynchronous. So we'll just say x.id equals ticket.id, and then we'll just in here we'll say underscore context.entry, which will be our existing ticket. We want to set the current values to our new values of new ticket. So we can say our description is equal to ticket description, our status, and also our priority. Notice we won't change the ID because that's our unique thing there. What we could do as well is this should also be an awaited function. And then once we've done that, we'll just do context, save changes, async. Don't need a true in that. Perfect. So what we're going to do is we're going to pass in a ticket and we're going to make a change to it, and then we will select that ticket and go from there. So what we can do now is we can go up a level to our interface, copy this line and put it into our iTicket service. We'll now need to implement this method as well, and we can just say await ticket repository update ticket, and once again we can now go to our ticket controller. We'll copy this, paste it, and we'll say update ticket. This will be a DTO again. This doesn't return something, so we can get rid of our result. And then in here we can just once again say it worked. Or technically what you could do is if you did want to return something, you could go ahead and pull down, so once you've saved it you could use the get method and return it. So for instance, what we could say is once we've updated it, let's just go and return the new one. So then we could then say ticket.id, for instance, rather than just returning OK. So let's go ahead and try that out now. So let's debug our application. And then in Swagger, what we can do is, first of all, let's go and get a record. So let's say we want to get ticket number 3. We can see our JSON here. So let's go ahead and copy that. And let's go to update ticket, try it out. We'll paste in our JSON from our previous one. And then we'll update the description, shall we? So let's say that has now been updated. So we can see for ID number 3, in our database, it currently says this is our second ticket. We can refresh. And if we call this API, we can see we did actually get an error here. It's part of a key, so can it be modified or marked as modified? So we must have done something potentially wrong in here. So let's go to our ticket repository. Okay, so because we're doing a this particular method of using these current values, it's not particularly liking it. So what we'll have to do is we'll do it a different way, and this is all good good knowledge, because it teaches you a different way of doing things. So if we just say existing ticket dot status equals this, existing ticket dot description equals this, and existing ticket dot priority equals ticket dot priority. So that's another way of going around that. So if we now hit HTTPS, let's move Swagger over. So now again, let's just go and get a ticket. So we'll say ticket number 3. This is my second ticket. We will now use the update function, paste that in. That has now been updated. Hit execute. We can see here it's now returned our success code 200, and it's returned our ticket again as we've told it to. So if you look at the database, we can see it has successfully updated our thing. So let's try and set a different status, for instance. So let's say we want status of 2, priority of 1. We can now see our status of 2, our priority of 1, and our ticket has been updated. So that is how you, in .NET 8, create a .NET Core Web API with dependency injection using Entity Framework and SQL Server. The methods we've shown are adding a record to the database, a function to get a record from the database, and another function to update a record in the database. I hope this course has helped you. I will put the source code to this project in GitHub, and I'll put that in the description below for you. If you did enjoy this course, if you learned anything from it, please do consider dropping a like rating on this video and also subscribing to the channel, as it really does help me out. If you have any issues, any questions, feel free to drop them below in the comment section and I'll do my best to come back to you. But in the meantime, I hope you have a wonderful day and I'll catch you all in the next one.
I'm still rolling with my gang and my G squad and my team. Try the commotion, it ain't nothing to write for the bro them. Like la di da di da da.